All right. Hello, everybody. Thank you all for being here today. Appreciate you making the time to join us this afternoon for what I think will be a really interesting conversation with Cohere. We have Sudip here from Cohere, and what we're going to be talking about is kind of exploring their journey from large language models as this sort of theory and research through to where we are today, and specifically where Cohere is today, from operationalizing those large language models in a way that allows developers, enterprises, researchers to build incredible AI-driven applications using that technology. So to begin, my name is Craig Alleva. I am the Director of Customer Engineering for Google Cloud Canada, and it's probably a term you haven't heard of before, but in essence, I work with customers in Canada specifically to help them adopt technology and modernize using Google Cloud. Joining us today is Cohere. So Cohere is an AI company out of Toronto. And what they do is they work on foundational large language models, and they use them to help enterprises solve really complex problems. And as you know, this is a topic of the day for the last year or so, for sure, in the mainstream space. What's unique about Cohere in particular, and I'll let Sudip kind of provide an overview in a moment, but what's unique about Cohere is that if you look at the DNA of the company, they are actually their founders are ex-Googlers who worked on the technology, the underlying foundational technology that comprises large language models today, the transformer architecture. So Aidan Gomez, Nick Frost, these folks are pioneers in that space. And so they have the depth and the knowledge beyond most companies to adopt this technology and provide value with it. So the links between Google and Cohere are very strong. Sudip is the Director of Engineering at Cohere. And maybe Sudip, if you don't mind, just kind of kicking off, maybe in your own words, I guess, talk to us a bit about, I'll jump to here, talk to us a bit about sort of Cohere in your own words. And then, so why did you join Cohere in particular? And then how has the engineering team sort of changed from where you are, from when you started to where you are today?
Sure. Firstly, I guess thank you for the opportunity. It's really nice to have the opportunity to actually talk about Cohere and our journey over the past 4 years or so. So Cohere was founded in 2019. Our CEO, Aidan Gomez, he was one of the original authors of the Attention is All You Need paper, which, as many of you know, was basically the foundational paper that led to the field of generative AI. He did that work while at Google, in Google Brain, and what he saw was the revolutionary impact that the transformer models were having inside Google, how it was getting integrated into a number of Google products, and he wanted to democratize that and make it accessible to a broader audience. And that basically was what led to the foundation of Cohere back in 2019. And obviously, like Aidan had that foresight to see the potential impact even before all of the generative AI buzz that we are currently facing. I joined Cohere 2 years later, around 2021. I was, like Aidan, also in Google. I was in Google Brain, and I was a researcher there. I kind of saw the potential impact that large language models could have. I shared Aidan's vision to make it happen, and that's why I basically left Google and joined Cohere, even though we obviously still actively work and partner with Google in a number of different directions. Since then, Cohere has obviously grown tremendously. When I joined, Cohere was, I guess, somewhere between a 40 and a 50 person company. Now we are more than 230 employees spread across 3 locations. We have a modeling, like a machine learning expertise hub, which is based out of London. Our primary headquarters is in Toronto, and then we do have a Bay Area office as well, where some of my teams currently stay. I think that's probably like a very quick summary of the last 4 years at Cohere.
Better than mine, yeah. So why don't we start with, you mentioned a bunch of growth. Cohere's gone through tremendous levels of hypergrowth in the last couple of years. How have you gone from where you were before to where you are now in terms of enabling developers and enterprises to adopt this technology? I think a lot of them have wanted to adopt it. They're not sure how. How have you met that challenge?
Yeah, I think one of the things that has happened, especially in the last 6 months to a year, is people don't necessarily ask the question of why I should use generative AI in my products. I think now the question has shifted to how I should use it, how I should integrate it into my products. And what we have seen is there's still quite a big gap in just being aware of the power of natural language processing and large language models and being able to actually make it integrated in a seamless manner into a product while leveraging the proprietary data sets that you may actually already have. So Cohere has been at the forefront in terms of just educating our, not just developers, but also enterprises through various mechanisms. Like we have a LLM university, which is a course structure that tries to go over many of the fundamentals as well as the potential use cases that can be driven by some of these large language models. We also have forward deployed engineering teams who work with large enterprises in a very hands-on manner to solve their specific problems. We have partners as well as customers with ranging from SMBs to Fortune 500 companies, including McKinsey, SAP, and LivePerson, who are using our models and have dedicated customer support from us. In terms of just the modeling capabilities itself, what I have seen over the last 4 years is even at the beginning of the last 4 years, we had generative models, which were basically truly foundation models. And in the sense that they were mostly continuation style models where the model, you give it a partial sentence and you ask the model to complete that sentence. The next evolution that I saw was instruction style models, where the models were now capable of following instructions. So write me a blog post. Instead of giving you the first sentence of the blog post, you ask the model to write you a blog post and the model writes it for you. The next evolution that we saw is conversational models, which is what created the most buzz, which is natural multi-turn instruction following. The things that we are working on actively today are retrieval augmented generation, which is combining the power of large language models with existing search and retrieval systems. And we are also working mostly in the research phase on action-oriented language models, which are capable of actually performing actions in the real world.
Cool, fantastic. So I know, as I've been working with Cohere now since 2021, and you use a lot of advanced technology in sort of supporting the business. You do massive training on a very large model using TPUs. You use GPUs for serving and a lot of other things. Can you talk a bit about sort of like how do you accomplish those tasks? I think a lot of folks hear about all these different technologies, all these different tool sets they can use to operationalize AI at scale. How do you approach that at Cohere? How do you use TPUs? How are you using GPUs today specifically?
Yeah, through our partnership with Google, we basically got early access to TPU v3s initially, and that's what we were using to do our pre-training of large language models. And then back in, I guess, 2021, we moved to TPU v4s as one of the early users of TPU v4s, and we got more than a 2x improvement in performance. And when I say performance, what we really care about is price per performance, because we want to drive down costs and we want to maximize the efficiency, and TPUs really gave us a good balance when it came to price per performance. We also had really good dedicated support through our partnership with Google, especially the JAX team as well as the TPU team. And it was very much a symbiotic relationship in the sense that we were early adopters. So we were kind of anticipating running into a few issues, which we did. And we were fortunate to have hands-on support from both the JAX and the TPU team to resolve these. And hopefully that led to a better and more reliable product, which is then helpful for all Google customers. So that's how we use TPUs. And then on the inference side, we want our models to be deployed in whatever environment our customers choose to deploy them in, which is why we made a choice to go with GPUs for our inference, because they are slightly more widely available across multiple platforms. We do use high-end GPUs for inference on GCP, and we use a number of peripheral services, including Google Kubernetes Engine, GCP monitoring, GCP logging, for basically building up our platform to serve these models efficiently.
Fantastic. So one of the things I'm curious about is model performance. So as things scale, How do you maintain model performance today? How do you handle tuning them over time? And then I think the other part is you've worked with a lot of different enterprises now, and they all have different needs, right? I'm sure they all have different needs from a performance perspective, but also scaling to security as well. How do you accomplish those tasks? How have you approached that today?
Yeah, as probably like many of you already know, you cannot necessarily improve a system that you cannot measure.
Right.
So we have invested heavily in a comprehensive evaluation framework that allows us to measure the performance of our models. Our evaluation framework is biased more towards enterprise use cases that our customers are seeing as opposed to academic benchmarks. We see a skew between academic benchmark performance and what use cases our customers have, and we definitely skew towards solving for our customers, which is why our evaluation frameworks are also biased towards that. In terms of the model performance itself, we have one of the strategies, or like one of the, I guess, design decisions that we made is not necessarily going for really big models in terms of the parameters, but rather trying to take a more holistic approach. We try to invest in high quality and high volume data to train our models. We try to invest in a lot of tooling that enables us to do rapid experimentation and iteration for newer generation of models. And then we also take into account the cost of inference and latency with which we can serve requests while deciding the size of the models that we want to put in front of our customers. So we have a couple of different sizes that we currently offer, but yeah, we don't necessarily want to chase just large models. We want to choose the right sized models for our customers. And finally, in terms of model quality, what we have seen is that a lot of large language models obviously suffer from hallucinations. So we have currently investing heavily in retrieval augmented generation, which allows these generations to be grounded on concrete data sets, as well as have citations so that the generation why the model actually produced a particular phrase or a piece of text because it is linked back to the source document from which the model derived that answer.
Amazing, awesome. So as you've had to scale, I'm assuming you've had to make some interesting technical decisions, some architectural decisions. They all have trade-offs, I'm sure. Are there any that stand out in your mind as very key architectural decisions that you made that either had a positive impact on performance or even a negative impact on performance? And what did you learn along the way in doing that?
I think let me focus first on the training side, and then I'll focus on the inference side. On the training side, the fact that TPUs have large interconnect domains allowed us to basically not use pipeline parallelism or there was no incentive for us to use pipeline parallelism, for instance, right? So we were mostly restricted to data parallelism and tensor parallelism, and because of the high bandwidth interconnects that TPUs offer, we were able to scale it to the sizes of to potentially like half a pod, half a TPU pod, or even 3/4 of a TPU pod, which is, by the way, a TPU pod is like 4096 chips. Some of the issues that we ran into, though, are more around reliability in the sense that you can imagine that at some point in the past when we were running data centers, they had tens of thousands of machines. Now, if you have a TPU pod, that TPU pod itself has a few thousand nodes. So, and if your single training job is now using all of these nodes, a single chip fails, then that can actually stall your training run. So how do you mitigate the impact? How do you make your systems more reliable was one of the challenges that we needed to overcome, and we did that with Google. On the inference side, we have invested heavily in smart batching solutions that allows us to achieve high utilization when we run inference on our large language models. So one of the key challenges in running inference for large language models is the fact that your requests can have various different context lengths, and that eventually translates into ragged tensors, which are non-uniform, and those are usually not very optimal when you want to actually run deep learning inference. So we have solutions which try to basically do smart batching so that we can have more even-shaped tensors, and we can maximize utilization. So that's like another, again, like design decision of how you can build potential peripheral systems that are sit outside the core model itself that can still significantly improve the utilization of your models.
Excellent. And are you thinking about, because you mentioned using the V4 pods, the 4096 chips, the challenge of, if there's an issue on that one, in the model, you might have to restart some of the training. How are you looking at things like multi-slice sort of training? We talked about new V5 chips that are coming. I know this is very early, but any thoughts on that? How you're thinking about it?
Yeah, I just saw the announcement about the new V5 chips. I'm pretty excited to actually give it a shot, both for inference on TPU V5s, but potentially also multi-pod training. Yeah. One of the things that I am particularly excited about is, as for instance, Cohere tries to train multimodal models, which more likely are going to try to basically require models of larger parameter sizes that do not necessarily fit a single pod. Or if we explore alternate architectures like mixture of experts models, which can be more easily parallelized across multiple pods, we would definitely be very interested in exploring the newer hardware specs like TPU V5s.
Got it, okay. And so one of the things that we hear often is this, customers struggle with, I think you've been able to overcome this, but there's a balance and a trade-off that comes down with, we want to have the most highest performant AI capabilities, but doing so in a cost-effective way. And so, and some of that, sometimes I've heard it from customers, it's hard to even estimate what, how much capacity they might need, how should they be thinking about GPUs, how they should, what's that balance and trade-off between training something really, really quick, but making sure it's cost-effective. How has Cohere thought through that to make sure at the end of the day you're able to offer a service that is performant but also cost-effective for both yourselves and your customers?
Yeah, as I mentioned earlier, we have been very cognizant of this latency and cost trade-offs when it comes to inference, which is why we did not necessarily just pursue large models. We did train large models of the order of like 300 billion parameter models, but the one we actually put in front of our customers is the 52 billion parameter models. We rather invest significantly more in higher quality data that allows us to actually get a good amount of good level of performance, even at modest scales, and that offers better price performance trade-off points for our customers. One of the things that Cohere actively is pursuing and differentiates itself is we want to bring our models to our customers. So we want our models to be deployed in enterprise environments instead of requiring enterprises to send their data through an API to us. Right. As a corollary of that, when enterprises do want to deploy our models in their environments, then they also need to take into account what kind of GPUs they need to acquire, how much that would cost. And we actively, as I mentioned, we work very closely with most of our enterprise customers. So we actively work with them to educate them on the various knobs that are available so that they can tweak the latency versus throughput. For some use cases, you may be okay with a higher latency as long as you get a higher throughput and higher utilization. For other cases, you may be very latency sensitive and you want a response within like a few hundred milliseconds. So we engage with customers to advise them on all of these various factors and how they can achieve the best price performance trade-offs.
So you mentioned about bringing those things, for example, from probably a regulated environment or something, bringing it on premise to handle some of the security aspects. What other things have you incorporated into Cohere and your offering to address security concerns that exist? Obviously, that's a really good one in terms of allowing the portability and to bring it in. What other aspects of security have you had to tackle in this space? Because I assume a lot of people are concerned about.
Yeah, absolutely. Yeah, what we want is basically to offer a wide variety of options for our customers so that they can choose the right solution for them when it comes to security versus privacy trade-offs. We obviously have a managed SaaS API, similar to many other companies, where you can just send your data to an API and get inference through our large language models that potentially is unacceptable for many enterprises who have sensitive data. We have an intermediate solution where our models are hosted in managed environments, for example, in Vertex. And the customers can then spin up our models through that managed platform. The managed platform takes care of scaling, infrastructure, all of that aspects, and you still get to use our models, but in a completely private environment so that Cohere doesn't see any of your data. Beyond that, we have an offering that basically allows enterprises to completely replicate Cohere's platform. So whatever we use to serve our customers in the managed SaaS, it is replicated entirely for you on a Kubernetes cluster in a completely isolated manner where none of the data, again, flows back to our to Cohere. And finally, we can do that in any of the public clouds. And if you're particularly sensitive, like if you're a government agency that requires to be on a specific Fed cloud, or if you have your own data center, then we also enable you to deploy that solution in that completely on-prem environment. One of the particular challenges that we are facing, as probably many of you are already aware of, is like the scarcity of GPUs. So one of our focuses has also been to diversify the hardware that our models can efficiently run on. And that enables us to be deployed in many different regions, as well as in many different on-prem settings, which doesn't necessarily have a specific type of hardware.
Yeah, I was going to say, because that is obviously a problem everyone's experiencing from a GPU perspective. What goes into, how do you make that decision then from a hardware, if you're advising a customer who is going to look at adopting Cohere and maybe there is an issue with getting certain GPUs, how do you advise them on which ones are going to make sense and what that will mean from their performance perspective?
Yeah, often customers themselves actually have requirements for regional locality because they are in a particular region. They have other compliant requirements that require you to be in that region. They basically, maybe like only a specific set of hardware is available in that region, in which case we try our best to make our models run on that specific hardware. Of course, it's not always possible. We cannot run on arbitrary hardware, but we try our best. We have been able to run on CPUs. We have been able to run on GPUs. We have done early prototyping of running inference on TPUs as well as a couple of other proprietary chips. Often what happens is that you can always run inference of large language models on other hardware as long as you are willing to take a performance hit in terms of either lower latency or lower throughput. And in many cases, that's perfectly fine, because what we have seen is that the value that the customers get by using generative AI in their products typically far exceeds the cost of running inference. So even if it's a marginal increase in the cost, it still might make sense for many of these use cases.
Yeah, no, it makes sense. So I'm curious about, you've been here now for 2 years, right?
2 years at Cohere.
And you've obviously been a part of a lot of the change there. When you look at where Cohere has come from, this sort of looking at it from an early science research perspective from that paper, through to developing, serving capabilities, through to security and operations, through to hypergrowth and the scale you're at now, that whole life cycle, that journey. Along the way, what's the largest challenge you think that sticks out in going from that idea to where you are now?
I think one of the challenges that I have seen is we are obviously in a very rapidly evolving field in which new papers get published, new ideas get bounced around, and it's hard to be focused on your vision and continue to execute towards that without necessarily getting distracted with all of these random ideas. At the same time, you always have the FOMO that you don't necessarily want to miss out on the next big idea, so you do want to keep tabs on it, but you still want to actually keep your team focused on executing what you actually intended to. It's been a challenge, but I think we have done fairly well so far, so we'll see.
Yeah, in the time you answered that question, 50 papers were released.
Potentially,
100 companies just spun up, yeah. No, I totally understand. So again, so when I look at portable solutions, I just want to make sure I got this for a moment from the openness and perspective. That can walk me through. You said other clouds can run other clouds on premise, edge, I assume, things like this. Or are you looking at that as an option as well?
Yeah.
Okay, excellent. Cool.
Yeah. We do want to be cloud agnostic, so our customers may have data that is sticky and they want to use a particular cloud provider or a particular region. So we are basically cloud agnostic. We obviously partner with Google, and we are available on GCP. We are also available on some of the other public clouds.
Yeah. And so lastly, I was thinking, when you look towards sort of the future, what can you talk a bit about from a, whatever you're willing to share, I guess, from a strategy perspective around how you plan to scale AI, new capabilities, features, things you're exploring? It could be related to openness, it could be related to security, portability, data controls, things like that. What does 2024 and beyond look like for Cohere from a strategy perspective?
Yeah, I think one of the things that I mentioned earlier is the fact that a lot of the customers are now thinking about how should we integrate AI or use LLMs into our products. Yeah. And as they do it, they're seeing that they actually need to address a lot of these challenges, whether it's security, whether it's as mundane things as versioning, right? So how do I ensure backwards compatibility as newer versions of the models get released? So we are actively trying to make sure that we have solutions for all of these more mundane aspects of things, which are necessary for productionizing LLMs in big enterprises. Secondly, I see that we will have continued emphasis on collecting and curating higher quality data, because what we have seen is that data can basically be the biggest, it gives us the biggest bang for buck in terms of improving model performance. And the third is, as I mentioned earlier, I have seen the evolution of models, and right now we are focusing on retrieval augmented generations, but we are also researching on action, on having LLMs be able to take actions. I would expect us to continue focusing on that space in 2024. We do have a intelligent enterprise agent that we announced recently. It's called Coral, that can basically be deployed in enterprises. If you can give it access, it has connectors so that you can connect it to your proprietary knowledge sources. The data doesn't necessarily doesn't need to be extracted out. The data can remain in whatever databases or knowledge repositories you have. The agent will be able to extract that knowledge from those repositories and use that to produce grounded generations. So that's something which we will do our initial launch soon, and that's something which will continue to be an emphasis over 2024.
Exciting, very cool. So there's in this room at this conference and others who watch this stream, there's a lot of organizations that are, as you know, looking at how to adopt this technology, right? Very new. They're facing a lot of pressure to answer to the boards around how are we going to do this. They're looking for use cases. They're trying to figure out how best to adopt this technology. How should they be looking at this? If you were to advise one of these customers right now about how do I find the right use cases, how should I get started, how would you advise them?
Yeah, so I think I would. We can probably do like a 1-hour session, which is going to cover that specific question.
We have 3 minutes.
So I think one of the things that I would advise people to do is start simple. Identify one particular use case and try to figure out how you can potentially use LLMs for that one particular use case, and then you learn something in that process, and then you can try to expand out from there. The second thing that I would advise a lot of SMBs and companies to do is that data is something which you have because you have a product, you have collected, you know what your users like, what your users dislike. And when trying to integrate LLMs into your product, you need to think about how can you use that proprietary data that is exclusively available to you, because that proprietary data is what is going to enable you to build a defensible product, right? LLMs are widely available. They are available by multiple providers. So just by using LLM, you won't be able to build a defensible product. The only thing that is available to you that allows you to build a defensible product is the proprietary data. So how can you leverage that proprietary data, whether it's through retrieval augmentation, whether it's through customization, where you fine-tune the models. So think about how you can use your proprietary data.
Excellent, I love that. And then I'll ask one more specifically on maybe use cases. You talked about, it was called Coral, right?
Yes.
Okay, so if you were to look at, if you were to suggest use cases that you've seen very successfully, that you might have done from Cohere perspective in helping customers, what are 2 or 3 that kind of stand out to you that tend to be pretty horizontal in nature, can drive a lot of value for people?
I think one of the use cases is basically just customer support. We work very closely with LivePerson. LivePerson is a company that basically provides intelligent conversational agents for many platforms. They have been in business for a while, so they had like massive volumes of conversational data. As I mentioned, like one of the ways that they could actually leverage that data is that they were able to fine-tune our models on that proprietary data, and then they could put those model generations in front of their customers, get feedback from their customers about how they feel about those generations, incorporate that feedback to improve the model performance, and have this positive feedback loop. So that's like one of the examples of how our models have been widely used.